Yo, my name is Josh. I'm not that posh, and I'm here to teach y'all about atoms. Yeah, his name is Democritus. He's an ancient scientist. He can do the maths while he takes his baths. He knew that he couldn't cut an atom. Yeah, he knew that one of them would be smaller than a breadcrumb. Oh, yo, there was a dude named Aristotle. He must have drank too much from the beer bottle because he thought atoms didn't exist. So he put up a fist and he called Democritus a liar. Ooh! And the people believed him, so they threw Democritus' theory into the trash. Dang, son! Then there was Dalton. He went and found fault in Democritus' theory. He said that atoms of the same element are the same, and he wasn't that lame. He said that atoms join with other atoms, and that was how they create different substances. Whoa! A century later, there was a scientist who said he could make the atomic theory greater. Heck yeah! His name was J.J. Thomson. He was kind of awesome. He used a cathode ray tube, but nothing really rhymes with cathode ray tube, so it doesn't really matter. Anyways, then Thomson found negative charges. These are called electrons. What? He made the plum pudding model. Yeah, he didn't dawdle. He said electrons were like plums and plum pudding. So that way there would be another word in this that doesn't rhyme. Yeah, I'd pay more than just a dime for more of these scientific terms to rhyme. Back to the science, though. Another scientist came along, and he went and proved Thomson wrong. His name was Rutherford, and he sent Thomson's theory to the underworld. Ooh! He made a new diagram. It had a nucleus in the middle of the atom. That nucleus was made of protons and neutrons. Yeah, the proton had a positive charge. It was balanced by the electrons. And the neutron had no charge, so it didn't really matter. But this is all really a bore. So let's learn about Bohr. Bohr's theory was even better, so it sent Rutherford to the nether. Kind of electron paths. There were paths that electrons could use, and electrons could jump. Yet he thought they could jump from one path to another. But what a surprise, even Bohr was wrong. Atomic failure! Then Heisenberg and Schrodinger came along. They were right. Well, at least that's what they thought some night in 2007. That's when this book I'm using was published. They said there were electron clouds, and they plowed down Bohr's theory. They said electron paths were not something they could predict, and it all clicked. And that's our current atomic theory. Wait, we have more vocabulary words. So now here's some vocab. These words are probably important. I'm not sure, though. And I think that's something my grade shows. Vocab time! Atomic particles are so small they have to be measured in atomic mass units. Protons are about 1 atomic mass unit. They had to tell the difference between atoms of different elements too. So they gave them all atomic numbers. Whoa! An atomic number is the number of protons in an atom. And each element has its own atomic number. Yeah! There's also a mass number. It's the sum of the protons and neutrons in an atom. They don't include the electrons because they don't matter. They're so small they don't get noticed. It's kind of like short people, huh? One more term now. We're near the end. I'm just as glad as you are, but we got to extend this for a few more lines for this last definition. Atomic mass. It's the weighted average of the masses of all of the naturally occurring isotopes of an element. If you don't know what that means, well, neither do I. But I guess that's why I'm almost failing this class. Well, now I have to go, but you should always know if you don't know these words, you'll get a D. If you think I'm lying, just ask Mr. P. That's what I know. So remember, even though it's December and winter break is coming soon, if you don't study these terms and you fail school, you'll be homeless on the street wondering why you were such a fool.